Thanks again. I think it's time now for COEXPAIR to take the floor.
Good afternoon to all and partners, participants. Alain Leroy, working for COEXPAIR. So our presentation will focus on resin transfer molding process, so also called RTM, to manufacture composite fiber reinforced parts, and more specifically, in this case, parts made with braided carbon fiber that have been produced in the context of the project. So the main objective of the project is to develop an innovative triaxial braid concept. It's done. Very good work. Simulation tools, we have done a very nice presentation, and manufacturing equipment, it's done and on the right path to produce after the summer. So all well done work so far. The validation of the possibility to transform those braids into composite parts needed to be done by means of the RTM process at different level, up from the coupon level plates to the propeller plate level, which is the application RTM Figeac is one of the partner, Collins Aerospace, is active in. This picture, you have seen some already in Baptiste's presentation and in the different presentation we saw today. There are many applications where braids, carbon braids are used. Stefan mentioned a number of those. One is the propeller blade of this engine that you see here on the picture on the right. There are not so many planes with propeller blade, you would say. Well, in the future, there is a very attractive market coming, which is the urban mobility and urban taxi, urban transport, so goods transport. So the future seems to go into that direction, and a number of propeller blades will be necessary. So a future for more braided carbon fibers. These pictures are taken from this YouTube video. I invite you to have a look. I'm not going to describe it all, but just insist on the fact that we have worked a little bit like Baptiste indicated, a foam core, a textile spar, and then the part enters into the braiding machine to be braided with a number of layers of the braid reinforcement before it goes into the RTM machine and be transformed into a composite part that can be used. As indicated, as you have been able to hear today, the COBRACOMP project at a very large scope, at really used a number of disciplines from which you are all coming. So braiding knowledge, textile knowledge, innovation, numerical simulation, part manufacturing at Collins, management and communication. We have heard Bérangère and Kevin doing that. The process RTM was our task at COEXPAIR, and we took the challenge to validate if the braids that were produced in the context of this project were usable, were processable in this project. Few words, very few words about COEXPAIR. So it's an SME located in Namur, Belgium. As you can see, we have a sister company in the United States, which give us a global supply of equipment to cover the aerospace composite industry. Small and agile company, 30, 35 people per company, and very skilled engineers with some gray hair for some of them, but not all of them. The RTM, resin transfer molding process, we are talking a lot about that, and it's out of autoclave process, closed mold, solid mold, as you can see here on this picture. The dry fabric, dry preforms is placed in the mold. The mold is closed. Resin is injected and infused into the dry textile, comes out. After a certain time, temperature is increased, or the material, the resin, thermoset resin, start to cure and give the final part after demolding. The RTM process is mainly governed by one of the law given here. It seems simple, but it's Darcy's law governing movement flow of liquid. It says that the resin velocity in the case of the RTM process will be governed by a number of parameters that we have there. The resin viscosity, as you can imagine, it should be low to infuse and penetrate fast in the reinforcement. Normally, as indicated there on the left, viscosity below 500 centipies or 500 millipascal seconds are ideal to infuse dry preforms. Length of the part will affect the efficiency of the injection. The pressure applied to the resin that is infused will be a key parameter. But two parameters coming from the reinforcement are key. Its porosity, the number of inclusions that are in the textile, but last but not least, the permeability that the reinforcement offer towards the liquid. Permeability, what is it? It's the ability of the textile or the resin, you can take both, to penetrate, to diffuse in between the different fibers. So I'm glad to hear from all of you, you want reinforcement braids with more fibers, with more compact fibers. It's nice, but it goes against the principle of this process that says, well, I need some room for the resin to go through. So too compact architecture as in this project, as indicated here, can be a barrier to the process, to the RTM process. So that's what we have tried to validate and to test. So we have worked in a very traditional way, a little bit the way the research is done. First, evaluating the resin system and the braids that were supplied to us at a coupon level. So we have seen from Baptiste a lot of results were generated at this level. We've received the braids that are here in the picture in plastic bags. We have transformed them into flat preforms. I have to say it's not easy cutting braids and making them flat and not moving into a mold. It's quite a job. And then transforming them after injection of a resin into a plate with the risk of the fiber moving during the injection and so on. But finally, we succeeded. And as you will see, we have worked at a coupon level, but also at a sub-element, sub-component level as well. Quite a number of plates were made in the context of the COBRACOMP project, about 45, in order to be able to deliver specimens for all the testing that has been described by Baptiste, but it is summarized here as well. So almost for every test here, almost for every configuration, 2-3 plates were necessary, therefore 45 plates. All the plates were dispatched to the different partner and characterized. So some material went to Inset, to Saint-Exbel, and to Ratier to have the characterization. All the plates were made with our equipment, injecting resin as indicated, that is RTM6 from Excel, a product that is qualified in aeronautic application, and it is a very well-known kind of a battle horse in the RTM for aeronautic application. Here, a little bit the parameter that we record during all this work. The press, the injector, and the mold are all connected to each other so that we can follow temperature, pressure, gelation, all kind of reaction that are happening during the process. A traditional process is taking something like 2 hours from the start of the injection up to the cure of the plates that we have just displayed before. Several thicknesses were made, several shapes, drop off, all kind of panels were made, flat panel, as I like to say. Because this was successful, because this was so well, all the results that presented by Baptiste and others were satisfactory. We decided to go and manufacture sub-elements, something that would be a look-alike blade propeller. So you remember a blade structure is a foam core, we have taken one, is a braid put around, is a spar made with different textile material, and another braid around. So we decided to go and to perform some injection with this kind of demonstrator. We had an existing mold at COEXPAIR, and with the knowledge gained during all the plates manufacturing, all the process parameters that were identified, we were able to create here a process, we call it in French a gamme, so it's a kind of a music how should I say, processing guidelines, and were able to repeat and create this composite part. Here are some more pictures with some detail. The concept of the core foam core reinforced material that we have made, the realization of the dry preform, introduction of the foam core inside the dry preform wasn't easy, but we finally succeeded. A lot of work in cutting fibers, making sure they are not moving, but finally, after injection, as you can see here on those pictures, two very nice preform that I think are good demonstrator of and good validation of the technology, the braids that were made, the injection in RTM, and all the curing and all the work generated so far can be successful and can be transformed into very decent, very good quality composite part. The market study that has been acquired by Agoria and supplied to the different partner is a very interesting tool now, because starting from this part, we can really see where those new braids, where those fast and easier to make braids can be applied, and really the wants and needs of the composite market are really well identified, and I'm sure we'll all be able to position those new braids into the composite market soon. The takeaway from this project, from processing point of view, first of all, the prototype braiding machine equipment that was illustrated before is really promising, and I'm sure that in September we will have a very good result and very good validation of the concept developed by Mr. Cahuzac and others, and put into practice during the last years. The triaxial braids that were manufactured during the project are easy to handle and to test. Despite my comments, it's not. It needs attention to be handled. It is not too complicated and can be used to make a very good quality composite part. I would maybe here and there add a preforming binder to keep the fiber together, but that should work. Preforming and compaction are suitable for the RTM process, as we have done it. Fiber fraction volume between 55 and 62% were really achieved, and without too many complications. And as we have seen from Baptiste, the mechanical performance are approaching standard, and should go there after us some more validation and some more work. On the RTM, we really believe that these new braids can be used to make flat panels, no doubt, to make sub-elements like we have done and have tried to demonstrate. Manufacturing procedure were elaborated. We have a fully automatized RTM process. Injector, press, mold are all linked, and we have injected one component and two component RTM6 materials. So the validation is there. Tomorrow we can go into the direction of some aeronautical application. As indicated already, the demonstrator combining hybrid reinforcement and foam was produced successfully. Those that want to buy a piece or receive a piece can just ask, and we will cut it into pieces. It can make a nice key holder in souvenir of the project. So in our opinion, the technology is ready to move on to the next level. Thank you for your attention and participation to all.